There's a place in our universe, a marble spinning in a vacuum. It contains life. It contains us. It may look solid and enduring, but now we can see it differently, across time, living and breathing. Across time, we can see that we, all of us, are changing this place faster than ever before. We can see the impact of the way we live. Of the choices we make. And see their consequences. There's a place in our universe. How we decide to treat it today will determine our future. What will you think? What will you do when you see our world changing before your own eyes?
Hello everyone, good morning, good afternoon. It's a pleasure to be with you at the Product Experts Summit. My name is Rebecca Moore. I'm the Director of Google Earth and the overall program that we lovingly refer to as Geo for Good. It's the Geo team's efforts to work with nonprofit scientists, institutions and citizens all around the world to leverage our mapping tools to make the world a better place. And we had a big launch this year. We had, for the Google Earth product, we launched Timelapse, the first time that we've told the 4-decade recent history of the planet with incredible satellite imagery experiences. And the organizers of the summit thought you might be interested in getting a deeper dive on that. And also we thought we would tell you a little bit of the history of Google Earth and of our program and how we also work with product experts, the community of folks that have supported Google Earth users for more than a decade and have really made a positive difference in the impact of our products. So hope you enjoyed that inspiring anthem video of Earth Timelapse, and now we're going to take just a little bit of a deeper dive. So Earth Timelapse, for the first time, as I said, puts this vivid depiction of our rapidly changing planet into the hands of everyone, everywhere. And you know, for the past 15 years, billions of people have turned to Google Earth to explore our planet from endless vantage points. We like to say if Google Maps is about finding your way, Google Earth is about getting lost. And we focused on creating the most realistic digital representation of the planet that has ever been put into the hands of the public, with features that entertain and enlighten. So with Timelapse, it's really, as I said, the biggest update to Google Earth since 2017. People can now see our planet in this entirely new dimension, time. With this new feature called Timelapse in Google Earth, 24 million satellite images collected over the past 37 years have been compiled for the first time into an interactive, explorable 3D experience. Time-lapse in Google Earth is a big leap forward because this once static snapshot of our planet is now dynamic, and it's providing ongoing visual evidence of Earth's changes from climate and human behavior occurring across space and time over 4 decades. So to help bring context to time-lapse in Google Earth, we've created 5 thematic stories using Voyager, which is Google Earth's storytelling platform. These stories take you on a guided tour of some of the most common changes you can see in the imagery: forest change, urban growth, warming temperatures, sources of energy, and our world's fragile beauty. So to get to time-lapse in Google Earth, you just click on the ship's wheel to access the time-lapse layer. And immediately we show you the 5 thematic stories. So let's take a look at warming planet. The first place we highlight in this thematic tour is the Columbia Glacier in Alaska. And in just 37 years, we can see 12 miles of glacial retreat directly in Google Earth. As you pan, zoom, and explore through the imagery, dozens of videos are actually being stitched together on the fly. And in a sense, what you're looking at objectively is we can all see global warming with our own eyes. This is a good example of how time-lapse distills that enormous archive of satellite data into an easily understandable picture of our changing planet. And we like to say that it makes the abstract concrete. So our hope is that this can ground everyone in an objective, common understanding of what's actually happening and inspire action. One of my personal favorites of time-lapse is how it reveals beautiful natural geologic processes that unfold over the timescale of decades, such as the beach sands of Cape Cod in Massachusetts, slowly shifting south. This particular view is captured in our featured locations collection, and it's called Mesmerizing Changes. We also wanted to make the time-lapse imagery accessible through video, and we've launched a new web page, g.co/timelapse videos. We've exported 800 time-lapse videos of interesting locations into open public use videos in both 2D and 3D. We hope that students and teachers and scientists and advocates, everyone will make use of these freely available videos in helpful ways. So now let's get into how we brought time-lapse to life. This is kind of a behind the scenes. Producing time-lapse in Google Earth was a huge computational task. It required a significant amount of what we call pixel crunching in Google Earth Engine, which is our platform for geospatial analysis, cloud hosted. We analyzed millions of individual satellite images, identifying and removing artifacts like clouds and shadows. We then computed a single representative pixel for every location on Earth and for every year since 1984, and then we stitched these together into a global cloud-free time-lapse video. It took more than 2 million processing hours to sift through those 20 petabytes of satellite imagery. Because we ran this computation across thousands of machines in Google's cloud, we had the result in a matter of days. On a single computer, it would have taken 230 years. All this computing was done inside our carbon neutral, 100% renewable energy matched data centers. The newest really transformative breakthrough that enabled time-lapse in Google Earth was developing the 3D graphics digital rendering technology in Google Earth itself. We're rendering, if you look at this, we're rendering or draping an enormous dynamic global 4.4 terapixel satellite imagery video animation over a complex 3D landscape seamlessly everywhere on Earth. And that's, if you think of it, that's a 4 million megapixel video. As far as we know, time-lapse in Google Earth is the biggest video ever created on the planet of our planet. As you fly through Google Earth, the landscape underneath you is effortlessly animating over 4 decades. And now billions of people around the world can experience this from their web browser or even from their phones. That's the magic. So we launched this on April 15th, and we've been really gratified by the reaction. It's gotten attention all over the world, and you've got leading climate scientists, for example, saying, "I would not be surprised if this one bit of software changes many people's minds about the scale of the impact of humans on the environment." And youth climate activists like Greta Thunberg is using Timelapse in documentaries she's making to mobilize people into awareness and into action. So now what I love to do is just take a step back and how did we get here? How did we get to this idea of Google Earth for good and Geo for good? And so we're going to start actually back in 2005 when I live in the Santa Cruz Mountains of Northern California, just about half an hour from Google headquarters. But I live in a beautifully forested area, the largest remaining stands of old-growth redwoods in Santa Clara County. And one day I opened the mail and got this kind of inscrutable notice that said, "Notice of intent to harvest timber." It's black and white, sketchy, grainy map with all kinds of lines that it's quite confusing. What are roads? What are contour intervals? And so on. Very few people could understand this, but it was worrisome to the community because it sounded like a logging proposal, but no one could figure out this map. Meanwhile, this new thing had just come out called Google Earth. Again, Google Earth had launched in June 2005. This is the summer of 2005 when we got this notice. And I thought, well, what if I could understand the plan better by studying the details of the proposal that they sent all of the community and remap the elements of that instead of on that sketchy black and white map, remap it in the full 3D satellite imagery of this new thing called Google Earth and see if we could get a better understanding of what was being proposed. So I did that over one weekend, and you can see here the elements of the plan remapped in Google Earth. And it was shocking when I was able to do that, what you could understand for the first time. For example, how close the logging zone was going to be to daycare center, nursery school, elementary school, and how the helicopters, these are SketchUp model of the helicopter, how helicopters would be landing and taking off, flying with logs over these community centers. When I showed this to the community, it mobilized and galvanized action because, as you can see here, you get a much better understanding of what's at stake, seeing it in this 3D satellite imagery as opposed to that black and white, grainy, sketchy map. A lot of community members got involved and contributed data to me, like this is a photograph of our mascot, Charlie the Beaver. He was our mascot because beavers are responsible loggers. We called ourselves Neighbors Against Irresponsible Logging, by the way, or NAIL. This is Google Earth at that time. This is Google Earth, basically version 1, after it had been acquired, a keyhole had been acquired and then turned into Google Earth. And here I am at a community meeting presenting this plan to raise awareness. It did end up galvanizing not only community action, but also political awareness. It was published in a lot of newspapers. It was published on the CBS Evening News, my animation in Google Earth of the logging, the so-called logging flyover. And it was seemed to be acknowledged as the first use of this tool, Google Earth, for empowering public participation in these kind of matters. Folks wrote in saying, I thought I understood the proposal until I saw it in Google Earth. And that I nearly fell off my chair when I got that much more detailed perspective on what was being proposed. Long story short, using Google Earth, we not only educated the community about the details of the plan, we also proved that the plan was not legal, and the plan was stopped. We were able to protect more than 1,000 acres of redwood trees using this new thing called Google Earth. And now that land is being not only protected from logging, but it's being set aside as a new public open space for permanent protection. The news came out that environmentalists used to sit in trees. Now they sit in front of Google Earth. So this was the start of my personal journey in using Google Earth for good. It also was my entree to joining Google. I became the tech lead for the Google Earth layers, and then started what we call the Google Earth Outreach Program, because NGOs all over the world were contacting me, asking me how could we help them use this tool themselves for their own projects. So with that, that's a little history, and now I'd love to turn it over to Sean Askey, who has a similar interesting history that brought him to Google to work on Google Earth, and ultimately to become Google Earth's engineering manager and work very closely with the product experts for Google Earth. So please take it away, Sean.
Hi, my name is Sean Askey, and I'm a developer partner engineer on Rebecca's Geo for Everyone team. I'm also the former engineering manager for the Google Earth team, and I've been lucky enough to have front row seats to Earth's history over my 14 years at Google. And so to start off today, I kind of wanted to show you some little treats from the deep past for Google Earth. So first, I wanted to show you a little bit of a video. This is rendered on an old Silicon Graphics workstation, the kind of workstations that they would make like the original Jurassic Park on. And this is a product demo called Space to Face that was kind of the birth of Google Earth. The future founders of Google Earth used this as a way of demonstrating the capabilities of their software and their hardware. But it was such a compelling experience that a lot of them decided to shard off and start their own company to create what was then called Keyhole Earth Viewer. So in 2001, this came out. This is what Google Earth, or what would become Google Earth, looked like when I first played with it. I think a friend of mine got a NVIDIA graphics card, and this was a demo software that came with it to show off how cool it was. And so I was kind of captivated. It was amazing. And then I forgot about it for a few years. And so a few years went by, and all this time, there was a community forming around this Keyhole product. Something called the Keyhole BBS was formed, looked a little bit like this, and it was a place for people to come and ask questions, bring their discoveries on the map. People would map things like submarines you could see from space or airplanes in flight, and they would share these discoveries. And it started this amazing community for educators, for hobbyists, for scientists, sharing their work in Keyhole. And later in Google Earth. And some of our current product experts actually date all the way back to this community and have brought that decade and a half experience to the product experts community today. And so Google Earth was launched as 3.0 in 2005. And this was while I was in grad school. I started playing with it. I taught myself KML, which is the language of Google Earth for creating maps, and did some pretty cool stuff with it, and ended up catching Rebecca's eye at Google. This was 2007, and I ended up joining the team that she had newly founded to bring some of Geo and Google's capabilities for public benefit use for environmental and humanitarian work. And so did this for many years, working with external partners, helping them use Earth and Maps and our different APIs, and eventually had the opportunity of taking over the Google Earth team as the engineering manager and leading the reboots of Google Earth. And so this is what Google Earth looks like today. This is version 9. We rebuilt it from scratch as a web and mobile app and launched that in 2007. And one thing I can say after that decade and a half perspective on Earth is it really takes a village. Just like with children, you need a lot of people to make something like this happen and work. And so I wanted to talk a little bit about some of the different roles that people play here at Google and outside of Google to make this such an amazing product and to support the people who use it. You know, you of course have product managers that figure out the strategic direction of a product, what features it should have in response to what users need. You've got the engineering teams that I managed, the software engineers that actually build the apps for Android, iOS, and web, as well as the Earth Pro desktop application. You've got UX researchers that go out into the field and ask questions about what are people looking for, what do they need out of a product, and designers who actually make the beautiful user interfaces that we use. Program managers are super essential to organizing, cat herding this cross-functional team to deliver results on time and on schedule. But I think in a lot of ways at the center of this is this community, the product experts. You are helping us provide support and taking in that feedback from our users, guiding people who might be lost and need help, bringing important bug reports in. And this is really important because a lot of Google engineers, may not be a surprise, don't actually interact with outside end users all that much. And so you bring a really valuable perspective with your experience and what you're hearing on the ground as far as how users are using our products and the challenges that they're facing. But this is really just the immediate nuclear family for any product team at Google. Beyond that, you've got legal teams, privacy teams, security teams. You've got executives in the leadership hierarchy that are involved. It just takes so much, right? And even outside of our team, there's a lot of other engineering and infrastructure teams. For example, the groups that acquire the satellite imagery, process it, and publish it in a way that Google Earth can download. The Street View teams, user photos teams, the people who put the roads and the points of interest on the map, the teams that support the search infrastructure so you can search for places. There's just so much going on here that really, at the end of the day, it's more like a city that is required to launch any product at Google. And it's a lot of people to manage. Despite all of this, it feels like a lot, but Google runs lean on every team, every cross-functional role that we have. We're always a little short for people. And I think some of that is a forcing function to really make us prioritize what's really important for a product and for our users. It also means we have to make some hard decisions sometimes about where we invest our energies. And so, this means, that a lot of the change that you see outside of the company and in the things that we launch and sometimes unlaunch is representative of this really dynamic environment that we have at Google. There's a lot of internal mobility, people move to and fro, leadership changes over sometimes, priorities change. We always have this focus on the future, chasing new opportunities, looking for the greatest impact that we can have with the limited resources that we have. And as you can imagine, this really requires good orchestrators. You need like an orchestra conductor to make all these things come together and produce a good product and a smooth user experience. And this is part of where all you as product experts come in. Navigating all this change is hard. It's hard for us. I'm sure it's hard for all of you. Depending on how long you've been a product expert, you've probably seen us go from Google Groups to the U2U Pistachio interface to Google Product Forums. Then we had Hadfield and now Tailwind. We're always changing and evolving to try to be better. But those changes are hard sometimes on our users as well. And this is why a lot of you play such a critical role in helping us to communicate that change and helping users navigate along the way. And so, first of all, a big thank you for all the work that you do. You're directly engaging the users every single day on the products that we support, Google Earth in my case. And you often have the best view on what are the top issues, what are the sentiments of the users, what are their needs. And so, as mentioned, we don't always have engineers out in the field directly engaging with users. And this is why your role is so critical. And also because there are things that, while you're inside Google, you can't see, both literally and figuratively when it comes to a product. Sometimes we might be unaware or unintentionally tone deaf about how a change might affect users, and we need your perspectives to understand that. Sometimes the bugs that we put out in the world by accident, like you literally can't see when you're on a standard Google device on our internal networks. And so I wanted to call out a few of these kind of examples where PEs have been essential for us in addressing those challenges. One of them, I just want to call out Cliff, Alchemist 251, one of our diehard, longtime product experts. He's also a diehard Linux user. And so, we have Linux here at Google. Most of our engineers use Linux, but it's a certain variety, a certain kind of standardized version of Linux. And we don't always see the problems that other Linux users outside Google might have. And Cliff has been instrumental in helping us understand some of those issues and resolving some of those. Another example, Panoramio was a much beloved product that we had. Unfortunately, for a lot of reasons, we had to turn it down, which was pretty hard on the community of users. And so, I got the chance during my tenure to work closely with our product experts on understanding those concerns of the community and iterating on a new photos experience, both in the new Google Earth V9, as well as the desktop Earth Pro experience, to bring as much user-generated photos into the product as possible, given a lot of those infrastructure changes that came along with Panoramio shutting down. The last one I want to call out, and Hazel, I think it was Hazel, will get a special shout out for this on our product experts team, was kind of this hamburger debacle that we had when we launched iOS Earth V9. And so what happened is that we launched the iOS version of V9 after web and Android. And as I mentioned earlier, sometimes it's hard to see the issues, the bugs, when you're on a standard Google device on our networks. And so we shipped to the App Store without realizing that part of our localization configuration was broken. And so all of the non-US English locales or languages like UK or Australian English, Mandarin, Cantonese, and Hebrew all looked like what you see on the screen. Instead of saying Voyager or search or places, we had these weird K hamburger something something menu options. And what you're looking at, like, these are the actual internal variables for these bits of text that need to get translated. And we didn't see this and catch this issue before shipping. Fortunately, we have a really strong team of product experts who noticed this before and as this started to hit social media. And that gave us a bit of a head start in starting to work on that fix, which can take several days or sometimes up to a week to roll out. And so I think that might have been Hazel. If so, thank you so much for helping us with that. And also, kind of the fun part of this story is the hamburger part gave us something to play with. We started getting a lot of flack on the Twitter sphere, on social media about, great job, Google, come on, like, learn how to be software engineers. We got some jokes about, openings in our QA department. We have a great QA team, by the way, but this slipped by all of us. And so it gave us this opportunity to play with the hamburger thing a little bit. And so while the engineers were working so hard to fix the problem and ship it out, our social media teams put out some fun blog posts, some fun tweets, playing with this a little bit and the hamburger theme. And so I think people responded pretty well to it. There were a lot of jokes. We started adding K. It's kind of a constant C++ thing when you're naming variables and constants. So people and we started adding K in front of a lot of the words that we were using on social media. And when we did the release, we played it up as well with the hamburgers. And what was great is that the response from users was pretty good as well. We got a lot of thanks. Travis on our team and others worked really hard to respond to a lot of the App Store feedback. Hey, it's fixed, check it out. And a lot of those low reviews got turned around quickly once people saw that we were so responsive. And we have a lot of you to thank for that ability to be responsive to those user needs. And so maybe just some perspectives from a former engineering manager on Earth. What are the things that you as product experts can do to help your team? You can bring continuity. So as I mentioned, there's a lot of change and turnover at Google sometimes. And a lot of you may be product experts for a product longer than a lot of the leaders that are involved with a particular product. And so if you've been around for a decade on a product, your perspectives on that evolution of what users need is great perspective. You're there to help voice both your own professional opinion, given how long you've worked with these products, what experts you've become, and those perspectives of the users that you're trying to help. I definitely recommend engage the product team that you're with. When I was engineering manager, we used to meet with our product experts every month, give them heads up on new features that are coming out, sometimes give them sneak previews to play with it, and also to kind of recap the top bugs and issues that they were hearing out there in the community. So with that, I just want to say, thank you so much for the time and effort you put into helping us make fantastic products and helping us clean up some of the bugs and messes we make sometimes. It has been a shining part of my time on Earth to work with a lot of you, especially considering my history goes back 15 years with Earth as well. And some of you, I even remember back from those Keyhole BBS days. So anyway, to all the product experts, thank you so much, and hope you have a great summit.
Thank you so much, Sean, and I echo his thanks to the product experts and Hazel in particular for helping us out with our iOS hamburger situation that could have been a debacle and ended up turning into something really fun with the community with your help. So, all right, stepping back, this is sort of the final part of what we wanted to share with you, which is beyond Google Earth, are there other ways that the Geo team, the Google Maps and Earth team at Google can leverage our unprecedented understanding of the real physical world to drive more environmental impact at scale? And in particular, around climate change. We know this is kind of an existential threat to all of us. There's common consensus that by the year 2030, we need to cut our carbon emissions in half and get to net zero by 2050. Cities, in particular, are an important opportunity for change because 70% of global emissions come from cities, buildings, transportation, and so on. Well, how can we help as Geo, as the Google Maps and Earth team? Well, think about the data that we're collecting, the satellite imagery, high resolution, covering up to 99% of the world's population, the aerial imagery, even higher resolution that we have for many parts of the world. And we have oblique imagery in addition to overhead imagery, the street view ground level imagery that we collect, and the user-generated content that are coming from millions of people around the world. We stitch that all together into, for example, that photorealistic image that you can see here of the landscape. But what if we could do more with that underlying data and generate insights that would help cities and help all of us navigate the kind of changes and action that we need to take? So one project some of you may have heard of, we call Project Sunroof. We're able to take the high-resolution 3D models that we construct of buildings and not just create that photorealistic landscape for you to look at of New York or Paris or whatever in Google Maps or Google Earth, but actually we can derive the solar energy potential of those rooftops. And not only for one time of day, but we can model it over the course of the day, including modeling the shadows that come from buildings and trees and so on. And so that we have a very high resolution picture over the course of the day and over the course of the year. Here we're looking at London for the rooftop solar energy potential. Really the best quality data that's ever been generated. And we're doing it not by going on these rooftops manually, but by doing it with our digital underlying representation. We've now generated solar energy potential for more than 100 million rooftops, more than 20,000 cities. And if you just Google Project Sunroof, you can enter your own address. And if we have data for you, we will tell you the rooftop solar energy potential of your own home. We've given that data to cities, and I'll speak more about this, and they're using it to make really monumental policy changes. But another way we can use Google Maps data is think about traffic data, the data we have on mobility that we're turning into traffic information. Well, think about it. We can derive from that activity data the carbon emissions of all that traffic over the course of a day, a week, a year, and aggregate that up into the overall carbon emissions due to transportation at a city level. This is critical because transportation is a main driver of emissions in cities, and cities are trying to take policies and try to understand what is their current baseline emissions, what are changes they could make, and if they make those changes, how does that reduce the carbon emissions from transportation? And they've never had good data to do it. And now we've aggregated this into what we call the Environmental Insights Explorer. Like thousands of cities all over the world now have this highly accurate data that they can use estimating building emissions, transportation emissions, the CO2 reduction opportunity from Project Sunroof, and even air quality, and I'll say more about that. So cities are already taking action because now they're informed with this data. So, for example, the city of Houston, Texas, which has previously been known as like the oil and gas capital of the world, they want to be leaders in the transition to green energy, to zero carbon economy. And they learned from our data that they have the potential within Houston city limits to generate 5 million megawatts of energy. And with that, they created a policy and incentives to drive that. So it's sort of giving them the ambition because they have the data that tells them what's possible. And this is happening in cities all over the world. Project AirView is doing a similar kind of thing for air pollution. We've instrumented Google Street View cars with environmental air quality sensors. And it turns out, and we've driven millions of miles now with those, that air quality is hyper-local. The quality of the air from one end of a block to the other can be 10x different. And so having that hyper-local street level monitoring is really, really helpful. Here's a map of one of the prototype drives that we did to collect this data and validate that it was good. And you can see by the color coding how the air pollution or the air quality differs, again, at a street level perspective. Whereas like the highways, for example, are very high in NO2, and some of the areas around parks, for example, are very low. We've given this data now for free to cities, and they're using this. For example, this is the city of Copenhagen, which we drove, and they're using it now to create specific policies around areas that are worse that they want to improve, for example, areas near schools, and how they're going to change traffic patterns and so on to clean up their air. As I said, we've given this data now to more than 3,000 cities, and our goal, our commitment, is to help hundreds of cities reduce their carbon emissions in aggregate by a gigaton of carbon by 2030. This is an ambitious target. The second area we're helping with is what are called nature-based solutions to climate change. So it's not just reducing emissions, but how can we strengthen healthy ecosystems like forests who are sequestering that carbon from the atmosphere. For that, we've invented a new technology platform. Actually, we launched it a few years ago called Google Earth Engine, which is a scientific platform for taking not just satellite imagery, but satellite data from dozens and dozens of different sensors, bringing it in every 10 minutes into Google Earth Engine. The data traditionally goes off these government satellites onto tapes in government vaults where it's very difficult to access. But with Google Earth Engine, we're bringing these streams of environmental and satellite data online into Google Cloud and making these data sets available with thousands of computers for analysis to derive actionable insights, environmental insights. The first big result of this was the first global map of the state of the world's forests, where they were healthy and where they were disappearing over several decades. And that was published in Science magazine. It ended up getting attention all over the world as the first detailed actionable map of the state of the world's forests. And actually now it's being used to monitor and help protect, for example, forests like the Amazon. It's not just about stopping deforestation. You may have heard of the Trillion Trees movement and so on, that if we can plant more trees, we can strengthen, we can clean our air and we can reduce atmospheric carbon. But where do you plant those trees? Where on the world is it suitable to plant trees at that scale? Well, an incredible analysis, the first global analysis was done a couple of years ago, powered by Google Earth Engine, called the Global Tree Restoration Potential. They determined almost 1 billion hectares of land around the world that were suitable for tree planting, and further, that if we did plant those trees, we could eliminate 2/3 of all of the man-made carbon that is in the atmosphere today. So it's a solution. It's like a recipe. It helps create plan, an actionable plan for where to do that tree planting. The last thing I want to kind of switch gears to is I mentioned that Google Earth Engine is bringing in all of this satellite data, every 10 minutes from all of these different sensors. There's one satellite called the GOES satellite that is measuring not just imagery, but heat, like thermal radiation. They call them hot pixels. You get the temperature of every pixel that you're measuring. And with that, Google Earth Engine is able to, if you're looking on the left, do near real-time mapping of wildfires. So you see those orange pixels are where the ground is hot. And with that, and this is very timely, right, with the increase in wildfires, with that, Google Earth Engine is now wired up to Google Maps and to Google Search. So every 10 minutes when there is a fire, we are updating the boundary of where the fire is, and it's showing up as a boundary in Google Maps. So we're really excited about that because with the changes in the climate, it's not just about what can we do to reverse or mitigate the worst effects of that, but how can we help the world adapt and be safe in the context of these changes. So I wanted to close with that because you all are focused on being helpful. We are focused on being helpful, to address these kind of global challenges. It takes a village, as Sean said, to come together and bring all of the expertise, the technology Google has, the helpfulness that you have in helping people with our products. Like that's what that makes a difference in the world. So thank you very much, and I do hope you have a great summit.